All right, so again, today we're doing 5.3, and we're going to look into 5.4. And I'm going to start by giving you a couple equations, a couple identities per se. 5.3 is called the sum and difference identity. So we're going to write these just at the top right in like this space up here, because that's kind of a nice clean space that we have. And I'm going to write sum / difference identities. Everybody okay? We all good? Okay. There's three of them, a sine one, a cosine one, and a tangent one. Everybody with me? Okay. So we're going to do sine of an angle plus an angle, and that's going to be very similar to one that's sine of an angle minus an angle. So again, we're doing sum and difference formula, so we're adding two angles. Just look at the directions. It says find the exact value, which hints to me that it's a no calculator, and it means that we're going to use our unit circle. Now, if I said get out your unit circle and solve for sine of 15, you'd look at your unit circle, you'd be like, I don't see 15 on my unit circle. However, I'm going to argue that we can find 15 by adding or subtracting two angles together to get 15. Okay, the formula for this goes sine of A cosine of B plus or minus sine of B. Are we good in the back? We good? Yeah, okay, it's just really loud. There's a thing we got to talk about. I'd love to do that. Sine of A times cosine of B plus sine of B cosine of A. A and B are just angles, so it's one angle plus or minus another angle. If you notice, I wrote plus or minus in the middle here. That means that the signs need to match. So if I'm doing adding two angles together to get A plus B, I'm going to add these together. So off to the side, I'm going to write signs match. You'll see why that makes sense in a second. I could spend time proving this out to you, but I don't think we need to do that. We don't need to waste time on that. If I had more time, we would definitely prove it out. If you take math classes in college, you'll prove stuff like this. If you don't, you'll never see this again. The next one is cosine. We're going to do plus or minus for cosine. So I can add or subtract two angles to find a new angle. If you notice for sine, it alternated when sine, cosine. This time I'm going to put both the cosines together and both the sines together. So I'm going to do cosine of A times cosine of B. And instead of writing plus or minus, I'm going to write minus plus. And then sine A, sine B. Again, these angles can be degrees, it can be radians, whatever. If I'm adding them together, when I go to my formula, I'm going to subtract them. So that's why it goes plus positive, negative, and then it goes negative, positive. If I'm minusing them, then it's going to be a plus in between them. So the thing I'm going to write off to the side to remember that is signs opposite. So my signs are opposite here. We haven't done anything yet, so you're probably like, I don't get this yet, but it'll come pretty quick. And then the last one is tangent. This one has a fraction, so we're going to write tangent of, again, A plus B. These can be any two angles. And it's going to be a fraction. It's going to be tan of A plus or minus tan of B on top. And then the bottom is going to be 1 minus plus tan A, tan B. And for this one, you should know that the signs on top should match. So if it's a plus, the signs on top are going to be a plus, and then the sign on bottom is going to be opposite. So let me write that, and then I will zoom out so you can do some copying down if you missed anything. So the signs on top match, and the signs on bottom are opposite. All right, so you should have all of this at the top of your page. We're going to use these to solve the rest of the problems. Anybody questions so far? Anybody still copying? Okay. I'm eating my breakfast now that it's almost lunchtime. Just how today's going. Today just got away from me. If you don't have your unit circles out, get those out too, because we're going to refer to those. Get your unit circle out. All right, can I keep going? Yep. I'm not going to make you memorize it at this point. Normally we would have worked our way up to having had it memorized for this. This year has just really like kicked me in the butt. I just like thought we would have time for things and we didn't, and then I didn't want to, you know, whatever. So it's just not that important. If you can use unit circle, that's fine. And so if I'm expecting you to do like sine of 30, like I'm about to have you do, I'll give you the unit circle. All right. Am I good to move on to letter A? Now we're going to use these formulas. So it says sine of 15. So I'm thinking of, okay, there's no 15 on my unit circle, but can you add or subtract two other angles that are on your unit circle to be 15? 45 minus 30, easiest one. You also could do 60 minus 45. It's going to give you the same thing. So 45 is going to be my angle A, 30 is going to be my angle B, and we're just going to plug and chug. So I'm going to do, you can still see your formula above. I got to zoom in so you can semi-read my writing. I'm going to do sine of 45 times cos of 30. I have to match my sign, so it's going to be minus. And now it's going to be sine of 30 times cos of 45. So I first just plugged it into my identity above with 45 for A and 30 for B. Now I asked you to use your unit circle, so we got to figure out what all of these sines, cosines are, and then plug in and simplify. What's my sine of 45? Root 2 over 2. What's my cosine of 30? Root 3 over 2. What's sine of 30? We're all just plugging away on our own. That's 1/2. And then cosine of 45 is root 2 over 2. If you have no idea where we get those, you got to come see me so I can get you all caught up to speed. If that was hard for you, let me know. I'm assuming you guys were quiet because it was so easy you were doing it on your own. Now we're going to simplify. So I'm going to multiply root 2 over 2 times root 3 over 2. You multiply the tops together to get root 6. You multiply the bottoms together to get 4. And then I've got 1/2 times root 2 over 2. Again, multiply your tops to just get root 2. Multiply your bottoms to get root 4. And the last thing I'm going to do is combine it to be one fraction. So root 6 minus root 2 over 4. And that's the best answer you can give. It's as simple as that gets. Not too bad, right? We're going to do two more. We're going to do a cosine one, we're going to do a tangent one, and then we're going to move on. If you're feeling good, I want you to move on to the cosine one and see what you can do on your own. If not, I'm going to leave it here for a second, then I'm going to move over there. All right, the cosine one says 165. What are we going to add or subtract to get to 165? Do you have an idea? There are two angles on your unit circle I could add or subtract to get to 165. Yeah, exactly, Becca. 135 and 30. That's the one I thought about. Did anyone think of different angles? Okay, that's fine. And when I give you this and like ask you to find it exact, you got to find it on your unit circle. I'm not going to say, oh, well, you had to add, 115 and something. Like 115 is not on our unit circle, so you're not going to get to use that. Now we're going to do our cosine formula. So I'm going to do both my cosines together. Cosine 135 times cosine of 30. My signs need to be opposite. So instead of plus, I'm going to write minus. And then it's going to be both my signs together. Sine of 135 times sine of 30. Then I go to my unit circle and I find all those pieces. Cosine of 135 is going to be negative root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 132 is root 2 over 2. And sine of 30 is 1/2, I think. Now multiply and then combine into one fraction. That becomes negative root 6 over 4 minus root 2 over 4, which is negative root 6 minus root 2 all over 4. All right, if you're done with that one, go try the tangent one. All right, how do we get to 195? Anyone know? 115.45 works? Anyone do a different one? Okay. I thought about doing 1 or 240 minus 45. That also works if you want to do a minus. But we'll do positive, that's okay. Got to plug this into my tangent. So I'm going to do tangent of 150 plus tan of 45 all over 1 minus, again, opposite signs on the bottom, tan of 150 times tan of 45. I think tan's just a little bit harder than sine and cosine because you have to like figure out what the tangents are. So like tangent of 45, I think I know that one. Does anyone remember what tan of 45 is? 1. We've done that one enough times. I don't have to divide root 2 by root 2 to get 1. But tan of 150, I don't know, kind of off the top of my head. If you go to your unit circle, it's a 30-degree angle, so it's root 3 over 2 comma 1/2. Negative root 3 over 2 comma 1/2. Is that the point at 150? Good, and then I divide the y over x. If you remember faster than me, maybe you would have already gotten to 1 over negative root 3. But we know we have to rationalize it, so it's negative root 3 over 3. So I had to find that before I could solve, and then I do have to remember tangent of 45 is 1. So I'm going to go plug 1 in for tangent of 45, and then negative root 3 over 3 for tangent of 150. So I get negative root 3 over 3 plus 1 over 1 minus negative root 3 over 3 times 1. I'm going to simplify it one step before I'm going to say that you're okay to stop, but I'm going to go a little bit farther today. I didn't explore how far I wanted you to go, but I'm going to kind of talk you through why I would keep going. I've got negative root 3 over 3 plus 1, and then the bottom, Negative root 3 times, negative root 3 over 3 times 1 is just itself. So it becomes a big plus on the bottom. So 1 plus root 3 over 3. I told the other class you're okay to stop here. It is okay to be done here. However, I'm going to keep going because I don't like fractions in my fraction. So just like from all the math I know, I don't want this fraction to be here. So I'm going to keep simplifying if I can. So I'm going to make the ones have a common denominator. So if you just want to watch and listen, you're welcome to, or you can keep writing with me. I want the ones to have common denominators as the root 3 over 3. So I'm going to make all my ones be 3 over 3. So that gives me root 3 over 3 plus 3 over 3. And then 3 over 3 plus root 3 over 3. So again, I just made all my ones just be 3 over 3. I can now combine them into fractions. One fraction on top is negative root 3 plus 3 over 3 divided by 3 plus root 3 all over 3. The last step I'm going to do is multiply by the reciprocal. So I've got negative root 3 plus 3 over 3 times the reciprocal, which is 3 plus root 3. There's a lot of 3's here. So those 3's cancel, and I get negative root 3 plus 3 over 3 plus root 3. That's not much prettier than what I told you. You could stop right here. But I like it better. Again, you can stop right here and call it a day. Anybody have any questions? Just trying to show you the most correct way, I think. All right. The next part's easy. You guys ready? Okay. This, I give you the formula plugged in. We're going to go backwards. So you saw how the last problem started with like tangent of 195, sine of 15. That's what my answer is going to be for the next part. So I've got 5 of these, and it's written out like the sine, cosine, or tangent. Sine 58 times cosine of 32 minus sine 32 times cosine 58. Which one does this look like? The sine identity, the cosine identity, or the tangent? The sine. The sine's the one where it goes sine, cos, sine, cos. So it looks like the sine one. So I'm going to do sine. I gave you 2 of the angles, 58 and 32. Am I going to add or subtract those angles? Add. Why? I'm going to disagree. I almost believed you for a second. I want a minus because in sine, you have to match. Remember, the signs match. So whatever the sign in the middle is should match what we're doing on the beginning. So since it has a minus in the middle, we're going to minus them here. You guys okay with that? Okay. So 58 minus 32 is sine of 26. That's it. Let's do one more. We're going to do D together. So this one says sine of 6, sine of 10, minus, and it should say cosine 6, and it should say cosine 10. It kind of got cut off by the printer, so put a little cosine 10 in on your paper. Now, it doesn't quite look like one of them, but which one is it the closest to? Sine, cosine, or tangent? Cosine. Why? Good. So in sine, it goes sine, cosine, sine, cosine. But in cosine, it puts both the coses together and both the sines together. However, it's not quite what we want. We want the cosine to go first. We want it to be cosine of 6, cosine of 10. In order to get that, though, we need to like factor out a minus, a negative sign. If you factor out a negative from everything, that makes my cosines positive, and it's going to make my sines negative. And then now this looks just like the cosine one, right? Cosine of 2 angles minus sine of those 2 angles. My angles are 6 and 10. Am I going to add or subtract those? Add. So cosine is opposite, so I'm going to add them. So that gives me negative cos of 16. I want you to take a minute and try the next three. So B, C, and E. E looks cut off, but I'll kind of write what E is supposed to be. Sine of 37 cos of 19 plus cos of 37 sine of 19. So go ahead and try B and C and E, and then we'll talk about it in a minute. And then we'll keep going from there. All right, take another minute. If you have no idea where to go, I'm here and I'll help you. All right. Letter B says tangent of 13 plus tangent of 18 over 1 minus tan of 13, tan of 18. Does this look like sine, cosine, tangent? Which one? Tangent? I'm doing 13 and 18. Am I adding or subtracting these? Adding. Really, you're killing it today. Either everyone else is too tired or just not doing what we're supposed to be doing. 13 plus 18, I believe, is 31. All right. Next one underneath that, cosine of 12x, cosine of 9x, minus sine of 12x, sine of 9x. Sine, cosine, and tangent. Which one does that look like? Cosine. Very good. Oh. And am I going to add or subtract the two angles? I give us a lot of adding ones here. Oh. And when you add them, that's okay. It's just going to be 21x with the degree. Hold up. Awesome. Thank you. X with a degree sign. Well, we can't find 21x. That is okay. We'll figure it out. All right, last one, E. Says sine of 37, cosine of 19 plus cosine 37, sine of 19. Is this sine, cosine, or tangent? Am I adding or subtracting these angles? Adding. It's the same. 37 plus 19 is 56. All right, how are we doing? Good. Answer to C was cosine of 21x. All right, we're going to flip to the next side, and we're actually going to practice kind of what's going to be on your quiz tomorrow, but using a little different tools than what's going to be on your quiz tomorrow. We're going to do 2 of these, and then I'm going to teach you a couple new formulas for the beginning of chapter 4 or section 5.4, and then we'll be done for today. I am going to skip letter B just because I don't want to do it. If I want to, I'll do it tomorrow. When I say verify, that's like all we did in 5.2 is I'm going to give you an equation, and you just need to make one side look like the other side. So one side, sine of x minus pi over 2. I need to simplify that. I need to combine it down to just be negative cosine. Now, before today, I would have not known what to do because all we had were our basic like trig functions like sine equals 1 over cosecant, blah, blah, blah. and my Pythagoreans, and this doesn't look like either of those, but I just taught you 3 new ones today, which are the sum and difference formulas for sine, cosine, and tangent. This looks like a difference formula of sine, right? My A is x and my B is pi over 2. We don't know what x is, but once I plug this in and get sine and cosine for pi over 2, I'm going to be able to look at my unit circle and compare what my answers are. So let's do it. So if I'm minusing these angles, I have to alternate sine of x, cosine of pi over 2. I have to make sure my signs in the middle match minus. Then I'm going to do sine of pi over 2, cosine of x. Any complaints with that? Plug and check. Now I'm going to use my unit circle to remind myself that cosine of pi over 2 is what? Cosine of pi over 2. 0. I don't know what sine of x is. That's why I didn't ask you. There's no x on my unit circle, so I can't use that. So sine of x times 0. And then what's sine of pi over 2? And then times cosine of x. Now, once we plug in 0 and 1, we can do some, just some simple math, some simplifying to get down to see what happens next. 0 times anything is 0, so the sine x goes away. And then negative 1 times cosine x, well, that's just going to have to stay as negative cosine x. And if you look, that's exactly what we were trying to match it to. We did it. 13. All right, that was pretty easy. All right, again, we're going to skip the cotangent one just because I don't feel like doing that. But the next one's pretty easy too. It says sine of x minus y plus sine of x plus y. Can you use your sine sum and difference identity to break these two up? And then we'll kind of see where to go. So I hit A and B. I do sine of x. Ooh, that's a mess. Cos of y minus sine of y cos of x plus sine of x cos of y plus sine of y cos of x. So these two came from the first one. These two came from the second one. Everyone okay so far? Okay. Now I'm here. We'll just kind of see what we can combine. I've got sine of x, cosine y. Let's see if we've got another like term. Not the next one. Oh, the third one is sine of x, cosine of y. That's two of them. So we can write that as 2 sine x cos y. And then I've got negative sine y cos x, and I've got a positive sine y cos x. I've got a negative of something and a positive something. They just cancel each other out. Oh, that's as simplified as it gets. Oh, and that's what we want it to equal. We did it. We did it. So you guys are laughing at me, but I spent many college classes just doing proofs, and that's what the goal was every time. We'd write page-long proofs, and you just tried to get what it equaled, and then we would do little signs at the end. So you had to either write QED, which means something in Latin, like I'm done, or I wrote this little check at the end, did a double X, and was that's the end of my proof. You kind of had to sign off on your proof that you were done. So at some college classes have these little blue books that you take tests in, and we fill entire blue books during tests of proofs. So this is so nice that we did one step and we're done. You're cool story. Your math is a lot. Don't do it if you don't want to. All right, last two we're gonna do. 5.4. We got, you know what? I'm just going to write them down. We'll solve these next time. We had a slow start to class today. We won't solve these. We'll solve them next time I see you because they're not even going to be on the quiz. I got a little farther in the other class, but that's okay. Let me write these down though. I do expect these to be in your notes. So sine of, we're doing half and double angles. So we just did sum and difference. We were adding or subtracting angles. Now I'm doing half of an angle. So if I took an angle divided by 2, I would use this formula. We can say plus or minus square root for sine. It's going to be 1 minus cosine of x over 2. For cosine, it's going to be square root of 1 plus cos of x over 2. And then tangent can be plus or minus 1 minus cos x over 1 plus cos of x. If you look at the problem below, the one that we're not going to solve, but we could. Why are you low battery, sir? You've been plugged in all class. I hope that's not a problem I have to solve later. Anyway, what I was saying is I'm going to leave this here so you can look at it. But if you look down to problem letter A, it says cosine of 15. We did 15 a minute ago where we did 45 minus 30. But we could also do 15 by doing 30 divided by 2. So we could also use this formula for my half angles as well. Bell's going to ring any minute. So this is where we're going to be done for today. I am not assigning 5-3 until tomorrow because I want you to focus on your 5-1, 5-2. But 5-3 will be due on Friday. Trying to get some of this done before spring break. Yeah, that's it. I'm going to stop the recording because you don't need to hear us clean up. Oh, I guess I don't need to.